Good morning, everybody. Welcome to sunny Monday morning of Chem 1211 with your host, me, Dr. White. Hi. Even though it may not be sunny the rest of the day because they're talking about thunderstorms thunderstorms later this afternoon. We'll see. But you don't have to worry, we're not going to get rained out. Oh, that was awful. Look out, awful humor Monday. All right, I have some important announcements to make. As you know, last week I told you there was a change, I was told, from the original policy of taking 2 tests in a final at the testing center at Glen Ellen, the main campus. Ooh, throat needs some tea. And that was changed. I was told that I and all the other 1211 sections on that are net, you have to take all 5 tests and the final at the testing center. On Friday, I had a great meeting with the manager of the testing center. And because of that, we were able to work it out. And let me go through the change I just uploaded this morning in my syllabus. If you click on this, and I'll scroll down to the changes. All right, why are you being slow on me? Well, that's weird. All right, thumbs up, people. You see tentative test schedule on your screen right now. Give me a thumbs up. Thank you. All right, now what have I changed? Instead of saying a date, it's given the week of. That's test 1, 2, 3, 4, and 5. All tests and the final exam will be given, and this is important, at the Glen Ellen Testing Center. That's the main campus at Glen Ellen. They're only open Monday through Thursday. For tests 1 through 5, you'll have from the week of like 9, 12, 22, that Monday through the end of Thursday to take the test at the testing center. And you can bring your own calculator, as I say, and I've worked that out. You will need a photo ID when you take a test or the final at the testing center. Now, one thing, test 5, normally I'd pick it up on Saturday, all 1 through 4, but test 5, I'm going to be lazy and pick it up the following Wednesday, so you'll have some extra time to take it. Don't tell anybody. And I'll remind you later in the semester. For the final exam, there'll be the ACS comprehensive final exam given during finals exam week. That week, you will have from Monday to Wednesday, 11 a.m. of the final exam week. That means all day Monday, Tuesday, and Wednesday morning to be done by 11 a.m. because that's when they're going to pick it up along with test number 5 because I'm lazy. And you'll take the test and then I'll get it back.
So we can't actually go to like closest testing center for us. We have to drive to the Glen Ellen, right?
That's the only one you can go to, the testing center in Glen Ellen, unless sometimes special needs students, whoever they are, sometimes will have in their letter where they use a scribe. And then like I had last semester, I actually had 2 in my class. They took that at the Center of Access and Accountability. But If it doesn't say it in your letter, all students will take it. And I mean, any student who's got special accommodations, everybody will take it in the Glen Ellen Testing Center. That's one of the things, I'm glad I had the meeting with Lori at the testing center on Friday. We had a Zoom meeting.
Do you think we can do something about it, like email someone in COD?
Well,
And
I'll tell you what, Anna, this is a personal thing. We can talk about it right after class. Okay?
Okay.
Or during my office hour tonight. All right, so once again, tests 1 through 5 plus the final, you will have to take at the Glen Ellen Testing Center. On tests 1 through 5, you have the week of the test I'm giving to take it from Monday to Thursday, anytime you want. I'm not sure when the hours are, but they've got a pretty good window. And then the other thing, which I did during the pandemic, I asked, but I was told they can't do it, and I understand why. How do you get your test back? First of all, after I grade the test, I will send each of you an individual email showing you how many points you got for each answer. Now, on the Saturday of the next test, I will be at the library right after I pick up the front entrance of the library. Right after I pick up the next test. And I'll have with me the test I graded the last test. If you'd like, come and pick it up. I'll be Saturday morning. Now, if you can't do it then, I will email a copy of each test so you can look at the test and think about what was your answer. All tests, I will go through the answers for each question the Monday after the week the test was given. All tests, I will go over the answer for all questions the Monday after the week the test you take. Now, the only thing is, I'll cut that out of the videotape. I like my special effects. I'll cut that out of the videotape, but if you can't make it to class, I will go through it anytime during my office hours. If you can't make it to office hours, let me know. I'll arrange for a special Zoom meeting with you. Any questions? All right, another thing. Tomorrow we'll do the first lab. You don't need your kit yet, but next week you will. So make sure if you haven't ordered your chemical kit from the company, it's in my syllabus. I can't think of the name. I think it's Carolina something, but it's in my syllabus how to do that. So make sure you order and get your chem kit for the labs this semester as soon as possible. Wow, that's a lot. We're done with announcements. So let's get back to chemistry. All right, thumbs up, people. Did everybody see matters, states on your screen? Thank you. All right, little review. The 3 states of matter are solid, liquid, gas. You should know. See, it even says it on the screen at the bottom. And know this, that solid has definite shape and a definite volume. Don't worry about the incompressible or compressible. And you should know a liquid has indefinite shape, definite volume. And you should know a gas has indefinite shape, indefinite volume. Anybody over the weekend or since we last met think about, ooh, the stuff in this bottle is a liquid? Or if you inhaled or exhaled, I like that, inhale, exhale. See what happens to my eyes when I do that on Zoom. Zoom affects me in an interesting way. But anyways, do you think that was a gas? Or did you touch something like a piece of paper and say, ooh, that's a solid? Or if you had ice cubes in something, that's a solid. Remember, chemistry is all around you, all around you. I stole that from SpongeBob. And it won't hurt you to think about chemistry outside my class. All right. Now, we talked about matter last Wednesday. And by the way, thank you for making me a YouTube star. Everybody's been looking at my videos. That's a good thing. All right. Remember, a pure substance is composed of only one type of atom or molecule, and a mixture is two or more substances made up of either different atoms or different molecules present. Now, when we talk about pure substances and mixtures and compounds, we talk about a pure substance, there's two types of pure substances. One is an element, and it's a pure substance that can't be broken down into simpler substances by chemical or physical means. If you have a bar of gold or silver or platinum, you can't break that down to anything simpler. It's an element. Now, there are things called compounds, and those are pure substances that can be broken down into two or more simpler things. Example, which I gave last week, water. Water is a compound, even though you can have pure water, excuse me, the water, if it's ultra pure, which you can't get, it's very hard to get, is made up of two hydrogens and one oxygen, and that you can break down to hydrogen and oxygen. Another compound, oh, I forgot another announcement. Quick announcement. Don't forget tomorrow, I will go through chapter 2 problem set. Not all of it, but key problems. And if you come to lecture tomorrow morning, I will also answer any of your questions. Now back to table salt, sodium chloride. And that's the white stuff you put on your French fries, which Dr. White needs like a hole in the head, but or other things when you cook. And sodium chloride is made up of sodium and chloride atoms. And you can break this down to sodium and chlorine. Don't try it at home. It's very dangerous. Now, the table salt you have, I'll talk about that you can buy if it's kosher. That means it's pure sodium chloride. Now, they have others that also have other things in there, like sodium iodide, which would make that a mixture. Now, a mixture is a physical combination of two or more atoms or molecules in which each substance retains its own chemical identity. And that you pour two things or mix two things together and neither one changes. What would be an example of a mixture? Not that I'm going to do it now. But if I took the water that's in this bottle, it's a liquid, and put in sodium chloride, a solid, and shook it up real good, I would have a mixture. Now, I could have also put in there sugar or other things too. Now, what are examples of mixtures? And you should be able to identify or give examples of mixtures you use in your daily life. Well, if I think about my kitchen, or better yet, how about my bathroom? Mouthwash is a mixture. Your soap you use is a mixture. Oh, this is getting serious. You go to your kitchen, your ketchup is a mixture. Your pop is a mixture. By the way, Dr. White, me, was born and raised in the Chicagoland area, and the stuff in a bottle or a can that's carbonated, non-alcoholic, we call pop, not soda. By the way, tea is a mixture too. So is coffee. Ooh, this is getting serious. This chemistry is all around us. Now, when we talk about chemicals or substances really that can be pure elements or compounds, these substances have what's called chemical and physical properties. I'll never ask on a test, what is a property? But that's a characteristic that distinguishes one substance from another substance. Quick, yeah. Everybody, thumbs up, people see physical and chemical properties on their screen. Thank you. Now, what's a physical property? Those are characteristics that can be observed without changing the basic identity of a substance. Another way of saying that are the distinguishing characteristics of a substance that are used as an identification or description. Now, I will never ask on a test, what's a physical property, but you should know, hint, you should know some examples. If you go out in the parking lot and you see two cars, different colors, guess what? That's a physical property. Let's go to the high rent district. This gold is this color. That's a physical property. My whistle has this shiny aluminum, I believe it's earth steel. That's a physical property. You can identify the color is different. Same thing with the wood of my whistle, train whistle. It's different. Ooh, now Dr. White's going to get personal. I'm a flashaholic. It means I love high-end flashlights. These come from a gentleman in China who's probably the best flashlight maker in the world. And you notice they're different colors. I don't know if I can show you this. I don't know if you can see it. This one that's blue has a blue light. This one has, I don't know if you can see it well, it's green. Or another way, the color of the buttons. This is green. I don't know why it doesn't show up well. This is blue. Oops. By the way, these are called throwers, and this one goes about a quarter of a mile, the beam. Same thing for this one. All right, I got my flashlights into my lecture. So those are physical properties. Another physical property, you could go into a classroom and say, who's super tall and who's average height. And I've had students in my class who've been about 6'7", 6'8". And one semester in a 12-12 class, I had a pair of partners in lab. One was 6'8", and the other, I think she was about 5'1". And boy, the difference in height was amazing when they were standing next to each other. Not that there's anything wrong being super tall or not super tall. Those are all physical properties. Now, chemical property is different from a physical property. And a chemical property, and I'll never ask you the definition of a chemical property, but you should be able to give examples of a chemical property. And that's a characteristic of a substance that describes the way the substance undergoes or resists change to form a new substance. It's also another definition. A characteristic of a substance displays only through changing its composition, becoming something new. Now, here's an example. A chemical property would be, unfortunately, if you get rust on your car, steel of your car body will rust. That's a chemical property. Now, the metal used for your car body, they put paint over it as a coating to protect it from rusting. The moisture and air, oxygen, causes rust. Now, how many of you have ever seen Back to the Future? 1, 2, or 3? Oh my goodness, you guys don't look. Give me a thumbs up if you saw Back to the Future. Well, I see one person. The car in that movie, the star of the movie, is a DeLorean. And a DeLorean was a car made years ago and went out of business, the company. And what was special about it was made from stainless steel. Unlike regular steel, which can rust, stainless steel doesn't rust, so you don't have to paint it. And that's a chemical property. What's another chemical property? Don't do this at home ever. Paper that will burn. Water that won't burn. That's why they use that to put out fires. The firemen do, and firewomen. I guess you call them fire persons now, well, trying to be politically correct, but they're very brave people. But that's a chemical property. Now, the fact that this is yellow is a physical property. The fact that the cotton will burn, don't try this at home, that's a chemical property. And turns out chemical properties and physical properties are an important part of our daily life. Example, I'll talk more about it. Now, we also have what's called physical change and chemical change. The difference here is the word change as opposed to property. And a physical change is a process in which a substance changes its physical appearance, but not its chemical composition. Now, what's an example of that? You should know. If I ask on a test, give an example of a physical change. Well, if you ever have some ice cubes in a glass and let them sit for a while, ice cubes solid, they become water, a liquid. They were water to begin with. Now, both ice and the liquid water are both 2 hydrogens, 1 oxygen, water. But in ice, it's a solid. When it melts to water, it's a liquid. Now, what's another example of a physical change? Oh, I got one. If you take water and you boil it, the water goes from a liquid to a gas. Uh-oh. Look out. Special effects time. Hokey special effects. Look out. It's a liquid and it becomes a gas. Oh, I won't use that again. Bad, Dr. White. But that's a physical change. So next time you're boiling water and you see the steam coming over, By the way, steam is a fancy name for water in the gas state. Guess what? You're seeing a physical change. Now, let's look at a chemical change. Now, chemical change is a process in which a substance undergoes a change in its chemical composition. These are called generally reactions, and we'll discuss reactions in later chapters. Now, I don't have an example of chemical changes. Let's think about some chemical changes. Now, I'm gonna get real personal. All of you probably had breakfast. Hopefully you chewed like my mother taught me when I was 2, real little, actually littler than that. Found out she wasn't lying. Chew your food before you swallow or you'll choke. And I did one time, found out she wasn't lying to me. But when you swallow it, it goes in your stomach and it starts in your mouth, but it really happens in your stomach and one of your intestines. By the way, the last time I took biology was freshman year of high school. Wow, that was a long time ago. Not that there's anything wrong with biology, but by then I knew I wanted to become a chemist. Yep, by then. But when it gets in your stomach, the food you eat, when it's digested, undergoes chemical changes. It's no longer the same molecules you put in your mouth. Your body, your stomach and small intestine breaks it down into new molecules, which your body can use to make skin, muscles, and a whole lot of other things. Here, what's left of it, my beard. But that's a chemical change when you digest food. What would be another chemical change? Now, I worked for a chemical company based in the Netherlands, even though the plant and research was here in Chicago, that got its start making candles. And it was called Unichem Chemicals, since changed its name. Ooh, that reminds me, Dutch lesson time. Whoa, come on. How many of you have heard of the cheese Americans pronounce Gouda? Give me a thumbs up. Well, at least one person has, maybe more. Well, anyways, that's from the city that's spelled in the Netherlands, Gouda, which I worked in. I used to stay in The Hague and take a train because Gouda, which is not the right way to pronounce it, is a small town, but it's a beautiful town. And the Dutch pronounce a G different than Americans. A G is a very hard CH. And because I speak Hebrew and learned Hebrew, which has similar sound, I was one of the few Americans who could say the name right. And Gouda in the Netherlands is pronounced Gouda. And I worked in Gouda. By the way, The Hague, which is Haag, and then it starts is in Dutch, is really not The Hague. In the Netherlands, they call Den Haag. And again, a G is a hard CH sound. But anyways, they made candles. That's how they got it started, making the chemicals and making candles. And the next time, I've got some beautiful hand-dipped candles from this one small little store in Gouda. That was a good customer. They're like this real big, this diameter, and they're hand dipped. So you can see the different layer rings when they dipped it. I haven't burned those, but I have other candles I burn. And when you burn a candle, the wax is melting, physical change, and then it's burning, chemical change. So think about it. When you light a candle and burn it, you're doing a chemical change and a physical change all almost at the same time. Now, what's really complex, and don't try this unless you're old enough to, if you take a match and light it, it actually undergoes 3 chemical changes to make the flame when you light a match. So those are all examples of chemical change, and you should know that. If I ask on test, give an example of a chemical change, well, the easiest one to remember is when you digest food. But I guess I tell you all organic chemists when they're young were pyromaniacs, like to burn things. And if you light a candle, make a flame. I did more than that in our alley behind my house, but you're doing a chemical change. Now, when you do a reaction or do chemistry, an important law is conservation of mass. And that means when you do a chemical change, like eat food, you're doing a chemical change. Matter is neither created nor destroyed in a chemical reaction. It's just changed. So when you break down your, say you had starches to glucose in your body, you have the same number of carbons, hydrogens, and oxygens, just they're in new different molecules. I'll never ask what's conservation of mass on a test or the final, but I'll use this concept later on. Now, I'm going to go through these slides because we're not going to see this on the test, but it's in this chapter. We talk about in our world energy, that's a component of the universe. And what energy really means is the capacity to do work. So energy is something we have in our universe. Example, electrical energy, heat is energy, the light is a form of energy. Now, when we talk about energy, and by the way, click, switches, will this be on the test? Let me do it formally. Click, the switch, will this be on the test, is in the off position. But these are some terms I may use later in the semester, and it's in the chapter now, so I'd like to define it. Kinetic energy is the energy associated with motion. If you play billiards and you strike the billiard ball with your stick, you're giving that ball kinetic energy because it's moving. Ooh, special effects time. Now, potential energy is associated with position, where something is. If you're at ground level, you have a certain potential energy. If you step up and go to a higher altitude, you have higher potential energy. And this also can be seen in molecules, not taking them higher, but it's associated. Now, switch is still off. Now, units of energy, joules is an important one, named after a chemist. Calories, kilowatt per hour, like your electricity. Now, when we talk about energy, a calorie, chemical calorie, is the energy needed to raise 1 gram of water 1 degree Celsius. So to raise the temperature of water, you need energy. And 1 calorie will change temperature 1 gram of water 1 degree C. Now, just for FYI, for your information, 1,000 chemical calories, KAL, equals 1 calorie, like the thing you see on the back of a package of food, how many calories per serving. You know how all the good stuff have too many calories. They do. You know, my favorite, Lay's sour cream and onion potato chips. I only buy those 3 times a year. As soon as I open the bag, it just evaporates, disappears. But that's what a food calorie is. And we'll be doing something with this in one of the labs. Now, when we talk about types of energy, there's electrical energy, which is associated with the flow of electrons. And next chapter, I will teach you what an electron is. Again, switch is still off. And then there's chemical energy. And this is energy associated with potential chemical changes. When you digest food, you need energy to break it apart. We call that chemical energy. When you take water and break it apart into hydrogen and oxygen, you need chemical energy to do that. All right. I stole this from the movie. This is Spinal Tap, which is a cult movie. And it's all right, but they have some interesting things in there. And one part of it is the band, that's the name of the Spinal Tap. Think about that name. But anyways, they were saying we play so loud that our amp only goes up to 10, but we turn it up to 20, the volume. And now, will this be on a test? The dial goes to 10. I've just turned it to 20. The next things are very important. Click, the switch is really on. Will this be on a test? And also, you need to know this. Now, important concept in chemistry is temperature. And you all are familiar with the temperature scales. There are different scales that show how hot or cold something is. Like, what's the temperature outside of the weather, the air? And there are 3 ways of measuring it. One is Celsius. And Celsius can be abbreviated by degrees C or the superscript 0 degree sign, capital C. Now, until when I learned it, it used to be called centigrade, but once in a while, I'll still use the old name. Now, next, we have another temperature scale named Kelvin. And Kelvin is not a referential degrees scale, it's an absolute scale. So that's why you don't see degrees there, you see K for Kelvin. And that's named after the famous English chemist, Lord Kelvin. And I can't remember his original name. And finally, the one you're most familiar with is Fahrenheit, also known degree F. And these are the 3 temperature scales. In chemistry, in the lab, we use degrees C, Celsius. If you go into chemical plant, I'll talk later about this semester, because I've worked in chemical plants, I've supervised in chemical plants, I've been sent to chemical plants by companies I work for to solve problems, both in the United States and Europe, and Canada, and Mexico. Chemistry's got me around the world. But anyways, in the United States, we use Fahrenheit. Now, Kelvin is used for very, very low temperatures, and chemistry when you're talking about gases, which when we get into gases later in the semester, we will use Kelvin. Now, interesting thing about Kelvin, there's a concept called absolute zero. That's known as 0K, Kelvin. Not degrees, it's 0 Kelvin. And this is theoretical because nothing in our universe is at absolute zero, at least that I know of. But this is the temperature theorized that when you're at absolute zero, all molecules, everything stops. So absolute zero is the temperature when all molecular motion stops. Nothing is moving, not electrons, not molecules, not atoms. In outer space, you can get close to absolute zero, but you're never at absolute zero. Let's do something real quick. If I have time, I do. And let's assume from Wikipedia, I don't know, but the temperature in outer space is close, but it's not absolute. It's 2.7 degrees Kelvin. I don't know why they put an S there, but they did, which is also minus 455 degrees Fahrenheit. Whoa, that is cold. Now, it's important to be able to convert from one scale to another. And you can see at the bottom, the old slide. I should really change this. There are three formulas. Now, switch is really turned up to 30. If it only goes up 10, I've just turned it to 30. Now, there are three formulas, and we'll practice this in a little while. First one is Kelvin equals degrees C plus 273. Again, Kelvin equals degrees C plus 273. Next one is Fahrenheit equals 1.8 times degrees C plus 32. Fahrenheit equals 1.8 degrees C plus 32. So, and finally, if I want to go from Fahrenheit to Celsius, it goes degrees C equals degrees F minus 32 divided by 1.8. Another way of writing this would be this. Now, good news. I really mean this, good news. And that is, I think I mentioned a couple of years ago, another faculty member challenged me about my tests and grading. I like to be challenged. It makes me think, which is a good thing in my mind. Ooh, that was bad. But anyways, and the challenge was on your test, are you testing if a student knows the chemistry, or are you testing if a student knows the chemistry and you're testing their memory? And turns out when I thought about it, I was doing the second one. I was testing their memory and if they knew how to do chemistry with the information. And I thought about that, what the other instructor had changed to, and I realized my test, I should only test your ability or knowledge of chemistry, not your memory. Those are two separate things. So what did I do? I came up with on all my tests at the last page or the last two pages, and these will be the tests you'll take in the testing center. You'll get this. I have important information. And these are things I used to make students memorize, but now I'm giving it to you. You still have to know how to use that. You're welcome. Whoever said thank you, I didn't see it quick enough. Anyways, everybody see on your screen important information, test number 1? Thank you. This is in the lecture section of Blackboard. If I click on that, and I have it both, well, I just have it as a PDF. And here, if you notice, I will give you those 3 formulas. There's other stuff. Well, that's all for test 1. I will give you those 4. And if you look at test 2, 3, and 4, important information, those are things I'll give you that students have to memorize, but no longer. So these are the formulas that you should know how to use. And again, here are the 3 formulas. Know how to use them. All right, everybody see the problem on your screen? Thumbs up, people. Thank you, Melody. All right, if the temperature of gas is 101 degrees C, then what is the temperature in Kelvin? Now, I'm going to go a couple minutes over into our break. You'll still get your break, but I want to do this problem. Now, I'll do this throughout the semester. I have learned when you look at a problem like this, it's called a word problem. Relax, I'll teach you how to do this. The first thing I do is I ask what to myself, what am I being asked to find? I don't know how I came up with this, but I'll put a question mark and whatever units, whatever I'm being asked to find. Then I'll ask, what am I given? This. And now once I have this, I don't have to look here again. Uh-oh, it's awful arrow today. So we want to go from Kelvin from centigrade to Kelvin. And if you look at important information, Kelvin equals degrees C plus 273. Next, now that I have this, and this will be important information, test number 1 given at the back, I can put in my degrees C is this. And now I can pick up my calculator. This I can do in my head. If I get it wrong, somebody correct me. And that's the answer. Now, a couple important things, how I solve problems and how you should consider solving problems on my test. And my test, I give partial credit if you do it right, but you push the wrong buttons on your calculator or you make a mistake. Now, first of all, what did I do? Over here, what are you trying to find? Temperature in Kelvin. What are you given? The temperature in centigrade. And now, did I do the wrong name again? Yep, I did. Well, at least I told you I would. I know it's 101 degrees Celsius. How do you go from Kelvin, from degrees C to Kelvin? This formula. which you're given. Then you put in the number here, and that's the temperature, 374 degrees K. And that's how you do this one. By the way, hint, this is how you might see it on a test. And let's take a break, come back in 5 minutes at 9:57, and we'll continue. 5-minute break, 9:57. I'm gonna get up and stretch. Oh no, I'm running late. Time to get going. All right, we're talking about temperature. And there are different scales to convert from one to the other. Now, one thing I didn't mention when I was doing this, everybody see my whiteboard with the problem on there? Thumbs up, people. Thank you, Melody. Thank you, everybody else. All right, 273 is an exact number. And what that means is this is 3 significant figures. My answer should be 3 significant figures to the right. Actually, it's 0 significant figures to the right of the decimal point. And therefore, that's why this is. Now, let's look at the other formulas. All right, everybody see the problem? If the outside temperature is 11.4 degrees C, then what is it in Fahrenheit? Well, what do? Well, first thing you should do is, what am I being asked to find? And I put a question mark. You can do this, write it, degrees F. What am I given? 11.4 degrees C. And now I no longer have to look at this because all the information I need to solve the problem is there. And is there a formula that allows me to go from degrees C to degrees F? And the answer is yes. And it's right here. Again, you will be given this formula, but you will have to know how to use it. Degrees F equal 1.8 degrees C plus 32. So I know degrees F equals 1.8 times degrees C plus 32. Now, 1.8 and 32 are exact numbers. And I'll explain that, what that means in a second. Maybe more than a second, but in a little while. So I now know degrees F equals 1.8. And what's my degrees C? Well, I took the time to put that over there, and it's a good thing to do when you're doing word problems like this, plus 32. Now, listen carefully. Important mistake or mistake students make is they add this or don't do the things first. You should multiply, then add. Sometimes I've seen students add 32 degrees C and then multiply by 1.8. Now, hopefully you've got your calculator. I'm going to turn mine on, clear it. I'm going to do 1.8 times 11.4, hit equal, I get a number. Now I have my calculator in scientific notation. And the answer I get, which is also would be now, here's where significant figures play a role in your calculation. Since 1.8 and 32 are exact numbers never play a role in determining significant figures. However, this number is not an exact number. And how many significant figures does it have? Remember, every non-zero number is significant. So this has 3 significant figures. And since you're multiplying, or you should have the same number of significant figures past the decimal as the number that has the fewest. Well, in this equation, this is the only number you use. So now we have to round this number off the 3 significant figures, keep the 5, keep the 2, keep the 5, use this to round off, is 4 or less. And that would be the answer. Now, if you wrote it this way, you can write it either way when there are not a lot of zeros, like don't write 20 zeros at the end of a number, use scientific notation. Again, round it off, keep the 5, keep the 2, keep the 5, and this should have 3 significant figures, and this is less than 4, I'll drop it. And that's what you get. So if temperature is 11.4 degrees C, it's also, and you don't have to put units. I always do on my tests. I'll never take all points for that. 52.5. Now, interesting story. When I used to go to Europe, the Netherlands, I worked for 2 companies, European companies. So I go to England, Germany, the Netherlands, Belgium. I only went to France once. I had to solve a problem at a plant there. But I'd go to those countries a lot. And I get up in the morning, what do I wear to go to work? And I'd listen on the radio or turn on the TV, and they'd have the temperature in degrees C. In my head, I'd have to do a quick calculation to degrees F, because even though in a chemistry lab, I know I have a feel for degrees C, when it comes to what kind of clothes you should wear when you go outside, I have to convert degrees C to degrees F Fahrenheit. Now, you may not have your calculator, and listen to what I'm going to say in a second. All right, what I'm going to ask you to do is stepwise work with me on this. First thing I'm going to ask you to do, I'll read it first. The temperature of a cup of tea is 35.2 degrees Celsius. What is the temperature in degrees? And this should be F. Degrees Fahrenheit. Right here, write down what are you given and what are you being asked to find. We're going to do this stepwise. What are you given and what are you asked to find? When you're done with that, only that part, give me a thumbs up. All right, I'll have to set up a poll. So what are you being asked? What are you being asked to find? Hopefully you all pick degrees F. What are you given? Degrees C. Now, what's the formula? Well, you should be able to look in the back of your test to find this. Now, I'll let you do the next step. I'll give you 15 seconds to what do you write here? Hint, fill something in there. I think I gave you more than 15 seconds. And the answer is, here's degrees C. And that's how you fill it out. Now, if you were to do this on tests and not put anything down, I'd say, well, you know what it is. Maybe your calculator broke or whatever. And I'd give you 3 or 4 points. If you didn't put down an answer, I'd put 0. It shows to pay your work. Now I'm going to pick up my calculator, clear it, 1.8 times 35.2, add to that plus 32, and my calculator in scientific notation gives me 9.536 times 10 to the first degrees F. Now, on test number 1, 2, 3, 4, 5, and I think the ACS does the same thing, final, it will say, please use proper significant figures for all calculated answers. Now, 1.8 and 32 are exact numbers. They don't play a role in this. The measurement, the actual temperature, how many significant figures? All non-zero numbers are significant. Uh-oh, I'm in my 3 significant figures. So now we have to round this off to 3 significant figures. Keep the 9, keep the 5, keep the 3. Use that to round off. Is that 4 or less or 5 or higher? And the answer is 5 or higher. So I'm going to drop that and increase the 1 in front by 1. And you could have written it also and that's the temperature here, T, if it's 35.2 degrees C. And this might be actually 3 to 5 points, depending on my mood. All right. If the outside temperature is 85.33 degrees F Fahrenheit, then what is the temperature in degrees C Celsius? So what are we being asked to find? Degrees C. What are we given? The temperature in Fahrenheit, 85.33. How do we proceed? Well, at the back of test number 1, you'll have important information. This, degrees C equals degrees F minus 32 divided by 1.8. So you don't have to memorize it, but you do have to know how to use that. You also have to know how to write. So this is the formula you'll be given. Now, important things. Numbers in a formula like this are exact numbers. The other thing, common mistake that students make on test number 1 and other tests where they have to use this formula, they divide the degrees F by 1.8 and then divide 32 by 1.8 and do the subtraction. No, you do this first, do the subtraction, and then the division. Whatever in the bracket you do first. So first of all, I'm going to put in 85.33 degrees F minus 32, then 1.8. I don't know when I finally learned this, but the more I let the paper do the thinking, the better my test scores were, especially in graduate school when you had some really, really hard tests. So now I can pick up my calculator, clear it, and do 85.33 minus 32. I get a number. I'm going to divide that by 1.8. And my calculator gives me this number. That's better. This number, and that's a lot. See, it's all, I don't know if you can see it. Let me do this. This is where you have to know how to round off. Can you see all those numbers? Now, the only number that's significant figure is this. How many significant figures is 85.33? Dr. White got out of his rut. Count them, all non-zero numbers are significant. This one, this one, this one, this one. So there's 4 significant figures. Therefore, our answer should have 4 significant figures. I'm going to let you try first, then I'll do it. Round that off to 4 significant figures. Your turn to have some fun. I'll give you another 15 seconds. Go. Go. Thanks, Dr. White. You're welcome. Got a clock up here with second hands I can watch. Not second hands, second numbers. Bonus time. Time's up. How do you round this off to 4 significant figures? Keep the 2. There's a decimal point there, but keep the 9. Keep the 6. Keep the 2. use this number to round off. Is that 4 or less or 5 or higher? Hopefully I'll pick 5 or higher. Therefore, everything afterward, the number I'll drop, increase this by 1, keep this there. You don't have to put units, I do. Oop, not degrees F. I've got Fahrenheit on the brain. Now, if you had written it in decimal form, as opposed to scientific notation, which a lot of you might do, either one of these would be correct. Oh, that's fun. Let's do this again. Again, what are we being asked to find? What are we given? To go from Fahrenheit to Celsius, you have to put this in. This formula, which you're given, degrees F minus 32 divided by 1.8. Put the numbers in, do the subtraction before the division. Do the subtraction before the division. Since 1.8 and 32 are exact numbers, this has 4 significant figures. It's the only number with significant figures. My answer should have 4. And if your oven has a temperature of 375 degrees F, then what is its temperature in degrees C? And I'll let you try solving this. And in important information, you would see the following. Boy, I got degrees F on the brain. Sorry about that. So why don't you try just putting in the numbers if you don't have a calculator, and I'll give you 1 minute. Go. Go. I like that. It's a race. No, it's not a race. Why don't you all please start trying it? See, I can be polite sometimes. If you're done, give me a thumbs up if you want to. And those of you who finish early, please be patient. I try and give everybody time to finish. If you want, you can turn on your webcams too, so I can see I'm talking to live people. All right, let's get going. If you haven't finished, you can watch the video again, stop it, and have time to finish it. All right, first thing I like to do is, what are you being asked to find? This. And I show that by a question mark, degrees C. Do you have to do this? No, but it's worked for Dr. White and a lot of my students. What am I being asked to find, given? What am I being given? 375 degrees F. Also, important information, you have this formula. So degrees C, to get that from Fahrenheit, degrees F minus 32 divided by 1.8. What's this number? Well, I took the time to figure that out. So now I'll put it in. And now I'll clear my calculator. It's important. I'll now put in 375 minus 32. Do the subtraction first, then divide by 1.8. And my calculator, once again, gives me this amazing number. And now on test number 1, it will say, please use proper significant figures for all calculated answers. And this is one of them. And this is the only number that will determine how many significant figures your answer is, because 32 and 1.8 are exact numbers that don't play a role in the number of significant figures your answer is. So how many significant figures is this? All non-zero numbers are significant. 1, 2, 3. So that means our answer should be 3 significant figures. I'll give you more than 3 seconds to round that off to 3 significant figures. Your turn. Bad news, I ran out of tea. Water will do. Time's up. Keep the 1, keep the 9, keep the 0. Those are my 3 significant figures. Use the 5 to round off. Is that 5 or higher? Yep, it is. So since it's not 4 or less, it's 5 or higher, I'll drop everything at that and everything after that. The number in front, I'll increase by 1. So I'll get this. This doesn't change. And if you wrote it in non-scientific or numeric way, which would be acceptable, and that would be your answer, 1.91 times 10 squared, or 191 degrees C. And those are formulas you should know how to use. See, it even says that. Hold on, let's make it really official. Dr. White's having a bad arrow day. Anyways, you should know how to use these formulas. In the past, you'd have to memorize them. I will give those to you in important information. Test number 1. All right, now I'm going to turn the switch, click off to the off position. There's something we're talking about energy, and that's heat capacity. All substances have what's called a specific heat. And the heat can be calculated from the following equation. The heat in joules equals mass times the specific heat, C, times delta T. Delta T is the change, delta. That's this letter, Greek letter right here. Delta means difference, and that's the change or difference in temperature. And we'll have a lab on this. I will not discuss this on tests or go over this. By the way, heat capacity and energy in chemistry, that's the study called thermodynamics. And one of the hardest undergrad chemistry classes I had to take was one semester they have of thermodynamics. And when I took it at IIT, Illinois Institute of Technology, my instructor was, I still remember, Dr. Wood, and he actually wrote the book. Wasn't that good of a book? And it was a hard, one of the hardest classes I had to take. I got to be in there. So I did a lot better than a lot of the people in there who barely made C's. And what made it hard, you have to memorize a lot of formulas, and we won't do this in this class, relax. You have to use calculus and differential equations. Luckily, I had those classes already, but it was one tough class. It was really tough. Now, if we look at this, can everybody see the lower left of your screen where it says 19, page 19 of 19? You see right at the bottom there? Thank you. Guess what? We're done with this chapter. We're done with chapter 3. So you know what that means? Time to be wild and crazy on Zoom. It's time for a new chapter, chapter 4. Before I move into chapter 4, public service announcement. Don't forget, you should be memorizing the 37 elements I asked you to memorize, like hydrogen, carbon, oxygen, sulfur, gold, lead, all those. You should know their chemical symbols and the names. Also, tomorrow, I will go through chapter 2 problem set in the lecture before our lab. And we'll figure out probably next Tuesday, because next Monday, I believe we have off for Labor Day. I'm pretty sure we do, because I have a dental appointment this Thursday and another appointment medical Friday. So I know. But anyways, next Tuesday or tomorrow, I'll go through chapter 2 problem set. Next Tuesday, a week from tomorrow, I'll do chapter 3 problem set. Big hint. You do good on my test if you've done the problem sets on your own. If you have problems doing the problem set or difficulties, come to my office hours, or if you're here in class, ask questions. But now it's time for new chapter, chapter 4. I see a question. I forgot to do the method. Well, in that case, I better do it now. Hold off on chapter 4. Who reminded me? Thank you. Thank you, Jasmine. I got plenty of time to do it. Let's do it. All right. This is going to be cut out of the video. And if you're not here in class, come to my office hours and I'll teach you this. Years ago, I'm done. I'm gonna cut this out of the video, but if you need more help, come to my office hour. And we're done for today. Wow, time flies when you're having fun with chemistry and Dr. White. And with that, don't forget, tomorrow we'll go through chapter 2 problem set. Do it before I do, so you can see if you have any problems and ask me. Tonight I'll have my office hour. And with that, I'll say, Gang gesund. I stole this from Granny. Gang gesund. And if you have any questions, I'll stick around for a little while. Bye now. Gang gesund. Thank you, Melody.